Okay, we're working on 12.4, arithmetic series and sigma notation. So now we're going to learn about series and a special notation for indicating a series. All right, find each sum by grouping specified terms for quick calculations. All right, so what we tend to do when we're adding these up is we'll look for things like, if this was 2, 3, 4, 5, 6, 7, 8, 9, and 10. Well, we have 10 plus 1, which is 11, plus 9 plus 2 is 11, 8 plus 3 is 11, 7 plus 4 is 11, 6 plus 5 is 11. So I have 1, 2, 3, 4, 5 11s. And I had 10 terms, so now I only have 5 11s, so it's going to be 55. That's actually times. All right, we're going to do the same basic idea here. Again, just changing my color. Okay, so if I add 10 and 100, I get 110. The one before this would be 80. 90. 90 plus 20 is 110. 30 plus 80 is 110. So again, I'm going to have 5 110s. So that's going to give me 550 for my total. All right, this is how this whole thing works. Now this is going by increments of 1, and the number I'm using is going to be 101. If I have 100 terms, I have half as many of the first and the last added together. So this is times 101. Okay, so that's going to be 5,050. Yeah. So we just added up all the numbers from 1 to 100 in about 10 seconds. Pretty good. All right, series. A series is the sum of the terms of a sequence. So a sequence is just the list of terms, and a series is the sum of the terms. The arithmetic series is the sum of the terms of an arithmetic sequence. Write and evaluate the series related to this sequence. So it's going to be 2 plus 5 plus 8 plus 11 plus 14. Okay, so we have, yes, that adds to 16, and that adds to 16. So I have 32 plus the middle 8, which gives me 40. Okay, sum of a series. The arithmetic series, S sub n, this is our formula. This we were just doing. It should be pretty straightforward. It's going to be the number of terms over 2 times the sum of the first term and the last term. Or this really long one, and that one's hard to remember. So I will generally always be using this guy. All right, find S sub 50 for the arithmetic sequence. S sub 150 means the sum of the first 150 terms. Okay, so we take, it's an arithmetic sequence, so we take the number of of terms, 150, divided by 2. And then it's going to be, not this one, the first term plus the last term. That's what I don't know. So I have to figure out our n is 150. Oh, I see. This is using our, basically our common difference, right? Our equation. That's why. Interesting. Okay. And our common difference, notice, is 4. So this is how we would find our last term. So our last term is going to be 7 plus 4 times 150. 2 times 150 is 300, times another 2 is 600. And it's minus 4. So our 150th term is 603. So I'm going to have 150 over 2, which is 75, times 7 plus 603, which is 75 times 610. It's going to be a very big number. 75 times 610. So it's going to be 45,750. Okay, that's S sub 150. Okay, the first thing I'm going to do is get rid of this formula because this is how they do it and it bugs me. All right, there we go. Oh, I'm also going to get rid of this, that. Okay, I know that S sub 7 is 91. Whoops. Go back to my tiny pen. 91. And that's equal to 7 over 2 times my first term plus my last term. Now, I don't know what A sub n is, but I can figure it out. Okay, so if this is true, I'm going to solve for A sub n. So if I flip and 7... Okay, I multiply both sides by 2 over 7. When I multiply the 91 by 2 over 7, 91 divided by 7 is 13. So I get 2 times 13, which is 26. These all cross out. Now I have 4 plus A sub n. I subtract the 4. A sub n is 22. What I'm looking for is D. Well, I happen to know this also is A sub 1 plus, well, I'm sorry, my n was 7. 7 minus 1, D. Well, that's equal to 22. All right, so I subtract 4. 7 minus 1 is 6D equals 18, so D is 3. Okay, so my first term is 4. My D is 3, so I have 7 and then 10. I know that's long and complicated. Okay. Hang on. Summation notation. This is important. We're going to use it a lot. You're going to see it a lot as you go through math. Is that sigma, that weird looking E. It's a Greek E, sigma. Sigma indicates summation. So how you would read this is the sum of A sub k from 1 2n is some number. Okay, and it's written out in this form. Okay, so let's look at this. So this is how this breaks out. The k is your index of the sequence, so that's the k, it's right here. All right? So as k goes from, it's like our n that we were using. So as k counts from 2 to 5, so in other words, I'm going to plug in a 2, a 3, a 4, and a 5 into this formula and then add them together. So what that means is k, when k is 2, I have 8 plus 3. When k is 3, I have 12 plus 3. When k is 4, I have 16 plus 3. And when k is 5, I have 20 plus 3. Now I add those up and I would have my answer. Okay, so it's going to be 30, 45, 50, 65, 68. All right, that's how that works. The meaning of all this. So this is going to be something you're going to have to learn. Okay, so let's look at this. Expand and evaluate. So k starts at 2. I've laid out 2, 3, 4, 5 because it ends at 5. Right? It starts at 2 and ends at 5. All right, so if k is 2, I have minus 4 times 2 plus 3. Minus 8 plus 3 is negative 5. 3. Negative 12 plus 3 is negative 9. Negative 16 plus 3 is negative 13. Negative 20 plus 3 is negative 17. All right, so I write this out. Negative 5 plus negative 9 plus negative 13 plus negative 17. All right, expand and evaluate. So with 4 terms, feel free to just add them up. You can plug it into the formula if you want to, which is going to be, there's actually only 4 terms, right? So it's the first term, 4 over 2 times the first term plus the last term. All right. So that's going to be 2 times negative 22, which is negative 44. Or you can just add it up. You need the formula if we have a large summation. If I say the sum as k goes from 1 to 600, what's the term? What's the sum? Much harder to figure out. So that's when you're going to use the formula. Write a simplified expression for each series. What they want is basically your explicit formula. No, they don't. Oh, the series. So you want the sum formula. So n in this case they wrote it for you. Okay, because it's using our sum formula, it's n over 2, and then the first term plus the last term. Okay, so that's basically all that is. So we're just going to distribute this in. You have n over 2 plus n squared over 2, which can be written as n plus n squared over 2. I'm squishing that in there terribly. I'm going to rewrite that real quick. so it's more legible. All right, sorry about that. I'm going to make this a little bigger. All right. So when I distribute, I get n over 2. That's when it's times 1. When it's times n, I get n squared over 2. I can put these together like that. Yay. All right, on this one, that's our general form for the sum of any n integers. This one is of a constant. So if we look at this, okay, I end up with n over 2 times 7 plus 7 is 14, which that'll turn that back into a 7, and now I just have 7n. And that's logical if you think of it. If I add 5 to itself, I add up 10 5s, I'm going to have 10 times 5. If I add up 30 2s, I'm going to have 30 times 2. So those are just some standard formulas we have for series. Okay, in natural numbers and in C. Okay, and we're done.